File, profiler.dd. The profiler records where the CPU was executing when the 1000 Hz timer interrupt occurred, so you can learn where time is spent. Use the prof depth argument to record a hit in the end routines which call the current routine, as well. When done collecting statistics, use profrep for a report. You might need a docmax to expand the command line window buffer to fit it all. Study the code. The profiler is very simple. You might want to enhance it or modify it to debug something in particular. File, quebecdd. A queue is a bunch of malloc, add chunks of MEM linked together in a circle with one PTR to the next value and another PTR to the last value. These PTRs must be stored in the first locations in the structure. File, quirks.dd. Quirks *, you run a risk of problems if you do file operations on the same file simultaneously because there is no file sharing / locking mechanism. Generally, the last write wins. * when using FAT32, TempleOS does not generate unique short entry names, the ones with S. Not all FAT32 file names are valid TempleOS names and it will complain. Do not access FAT32 drives not dedicated to TempleOS. Disable them with DRB enable, off, or they will generate error messages. FAT32 involves a long and short name for each file. * the STK does not grow because virtual MEM is not used. I recommend allocating large local vars from the heap. You can change MEM_DFT_STK and recompile kernel or request more when doing a STOM. * the syntax highlighting occasionally glitches. The compiler doesn't. * call DSK change, when you insert a new removable media. * accessing CD/DVDs is flaky. Try DRB, or DSK change, twice. * you can only extern something once. There is a variant called _extern which binds a holy C definition to ASM sim. This, too, can only be done once. * a terminal task has a cdoc document structure that remains active even when you change fsdraw_it. To prevent links in the cdoc from being activated when the user clicks in the window, do one of three things: A. Doc bottom, followed by doc clear, to clear the cdoc so it has no active widgets. B. Disable window mgrbtt and click checking with fswin_inhibit set to mask with _self_ms_l with _focus_task_ms_l _d with _self_ms_r with _focus_task_ms_r_d. This inhibits window mgr operations but still generates messages from VTT and clicks. * switch / case stmts alloc a single jump table do not use with wide, sparse ranges of case values. * don't do a Godot out of a trot. * a Godot label name must not match a global scope object's name. It's not worth slowing down the compiler to handle this case. * memcpy only goes forward *, ACD, CMD must be followed by 2 semicolons if a number included is after it. This is because the preprocessor processes the next token ahead. * the assembler's error MSGs are often off by a line and undefined are cryptic. * the last semicolon on the CMD line is converted to a DBL semicolon because the compiler looks ahead before doing a CMD. This normally has no negative effect, but when entering if stmts with else clauses it presents problems. * you can do a class FWD reference by using extern on the first declaration, but you can only do PTR references to the class. * when doing something like u0 main, u16 *w equals 0xa0000, *w equals 0x8000, the equals will be coded as a u32btsinst resulting in a u32 access instead of a u16 access. This affects some hardware operations. * compiler warning or error message line numbers will be off if you have a block of word graph comments. You might press before doing an editor Godot line number command. File, redc.dd. redc file system. The redc file system is a simple, 64-bit, file system which is similar to FAT32, but with absolute block addresses instead of CLUS, fixed size 64-byte directory entries and no fat table, just an allocation bitmap. ACLUS is just one 512-byte sector. Files are stored in contiguous blocks and cannot grow in size. Number defined CDIR_filename_len38/ must include terminator 0. The following bit field shows valid 8-bit ASCII file name characters. U32 char_bmp_filename 8 equals 0x00000000, 0x03ff73fb, 0xefffff, 0x2ffffff, 0xfffff, 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 public class directory //64-byte fixed size U16 advert //crs_attr_dir. I would like to change these. U8 name CDIR_filename_len //cchar_bmp_filename, filename check I64 plus, BLK, //1 sector per plus. I64 size, //invite C datetime, //C datetime, implementation of datetime, public class credcboot //redc is type FAT32 in partition table to full BIOS. U8 jump_an_nop3, U8 signature reserved for, //mbr_pt_redc equals 0x88. Distinguished from real FAT32. I64DRB_offset, //4CD/DVD image copy. I64 sex, I64 root_plus, root_blk, I64 bitmap_sex, I64 unique_ID, U8 code 462, U16 signature 2, //0xA55, C:/kernel/blkdev/file sysredc.hc and :/adam/opt/boot/skazordc.hc. Files with names ending in .z are compressed. C:/kernel/compress.hc. To replace ISO 9660, make hard drive partition image of a measured size and copy onto a CD/DVD starting at about sector 20, with El Torito booting. 5 12-byte sectors will be placed on top of 20 48-byte CD/DCD sectors, so there will be 4 blocks per CD/DVD sector. redc file system has no bad block table and no redundant allocation table. See blockchain for redc allocation bitmap discussion. See reliability for redc reliability discussion. File, reliability.dd. redc reliability TempleOS is like the 1040 easy tax form compared to the full 1040 form. Obviously, it is simpler. If you allow mission creep, pretty soon the 1040 easy looks just like the 1040 and the messed up 1040 easy has no purpose. The Commodore 64 had a file system that was simple enough for peers in my generation to enjoy the thrill of knowing exactly what is going on at the hardware level and writing fun projects to access it. My primary design criteria is simplicity. If it is simple enough for only 100,000 people to learn, let's try to make it simpler so that 1 million can learn it. Obviously, we don't do bad block tables, or redundant FATs. We use the simplest possible technique, a contiguous file-only allocation bitmap, not blockchains or FAT tables. You can be a good toy or you can be a good professional tool, but not both. TempleOS's file manager will start too slowly once a few thousand files exist because the file manager makes a list of all files on startup. Do not have more than a few thousand files or the file manager will not function. You are encouraged to keep your entire drive limited to, maybe, 100 mega files because you are supposed to operate as a kayak instead of a Titanic. If you do this, backing up will be only a minute or so and you should do it at least once a day. Third-party software should be run from ISO files or CD/DVDs directly, without installing to hard drive. Multimedia graphics and sound is, basically, forbidden. If you ignore this, all hell will break loose because memory will fragment with large files and the original vision of Kayak hard drive back UPS won't work. Commodore 64 is a trademark owned by Blade Holding NV. File, requirements.dd. Requirements for TempleOS user skills required * knowledge of the C programming language. Supported hardware * x86_64 PC compatible computer. Obviously, you need 64-bit hardware for a 64-bit operating system. * 640x480 16-color VGA graphics. * most keyboards and mice. * minimum 512 MB RAM. * internal PC speakers. * CD/DVD ROMs, not SCSI, but only Red C file system. * ATA and SATA hard drives. Unsupported hardware * no graphics acceleration. * no sound cards. * no networking. * no USB devices, except keyboard and mouse in legacy mode. No, you can't use flash memory cards. * no printers. File, resource.dd. Graphics Sprite Resource Help. A sprite is an ordered list of elements such as lines, rectangles, bitmaps, and color changes. In a program source code, you first make a sprite somewhere outside a function. Then, you insert a pointer to the sprite as an * element arg when calling sprite, or sprite3. See sprites. You can create a sprite macro on your personal menu with a payload of holy C source code to execute when it excs back to the CMD line. If you check pop-up, it will spawn a new task and run the payload. A pop-up macro can be placed in any document. File, scoping linkage.dd. Scoping and linkage JIT compile mode makes use of the current task #sim table and its parent tasks tables. It fetches sims from parent tasks tables if not found locally in the current tasks table, and it places new sims in the current tasks table. Conceptually, sims are at the scope of environment bars in other operating systems. When a sim is placed into a table, older sims with item names will be overshadowed if they exist. Duplicates are not allowed in many cases, especially in ASMBLKS. Duplicates are allowed, by design in other cases, so that you can repeatedly include the same file from the CMD line while developing it. Or, so you can repeatedly declare a function with a standard name, like drawIt. This case might occur when the Atom task is starting uploading in many little utilities. Extern binds a new htt_fun or htt_glbl_ sim to an existing sim of the same name if it exists in the sim table, just-in-time code. It also can be used to generate an FWD reference. Import binds a new htt_fun or htt_glbl_ sim to a sim of the same name imported from the task sim table at load time. If no sim exists to bind to at load time, the code using the sim will be left incomplete until the sim is defined. Extern binds a new htt_fun or htt_glbl_ sim to an existing sim, of a different NT name. It must exist in the sim table. Basically, this binds C to ASM. Import binds a new htt_fun or htt_glbl_ sim to a sim, of a different name imported from the task sim table at load time. If no sim exists to bind to at load time, the code using the sim will be left incomplete until the sim is defined. Basically, this binds C to ASM from elsewhere. Ahead of time compilation global scope /function scope code heap /data heap /stack /register task #entry export syssim /define /function /class usage scope module /asm local /asm blk /task and children /function usage scope glbl/asm local/remainder/full-block remainder static var/dynamic var/no init allowed are dubs allowed within the namespace. A dub overshadows the original. Dubs allowed /no dubs but /warning unless closed out ASM export label, GCSMGNASM label, GCMGNASM local at label, GCALNASM import label, GC Mr. NASM export label, FCSBGNASM label, FCBGNASM local at label, FCALNASM import label, FCBRNC GoTo label, FCFGN number define X Mr. D function GCS Mr. D RFRFRN RFSFRN static RFCFRDN GCS Mr. D GD Mr. ND class G Mr. D class member G Mr. P extern class G Mr. D extern function GC Mr. W import function GC Mr. D import var GC Mr. D underscore extern function GC Mr. D underscore extern var GC Mr. D underscore import function GC Mr. D underscore import var GC Mr. D just in time compilation global scope / function scope code heap / data heap / stack / register task hash entry export sysm / define / function / class usage scope module /asm local /asm blk /task and children /function usage scope glbl /asm local /remainder /full-block remainder static var/init /dynamic var/init allowed /no init allowed are dubs allowed within the namespace. A dub overshadows the original. Dubs allowed /no dubs but /warning unless closed out ASM export label, GCSTGNASM label, GCBGNASM local at label, GCALNASM import label, GCTRNASM export label, FCBGNASM label, FCBGNASM local at label, FCALNASM import label, FCBRNC GoTo label. FCFGN number define XDTRD function GCFTRD RFRFRN RFSFRN static RFCFRDN GCGTRD GDGTRSD class GCTRD class member GTRP extern class GCTRD extern function GCFTRW extern GCGTRD extern GDGTRD underscore extern function GCFTRD underscore extern GCGTRD asterisk. GoTo labels must not have the same name as global scope objects. GoTos are rare and I don't want to slow the compiler and add code to fix this. You will get errors if a collision happens, so it's not very dangerous, but the error message is baffling. Asterisk the member names pad and reserved are special because multiple instances with the same name are allowed in a class. Asterisk use reg or noreg in front of local var names to override automatic reg var allocation. You can, optionally, specify reg after the reg keyword. Asterisk local non-reg function vars can be accessed in ASM VLKS with NIRBP for example. Asterisk GLBL vars and functions can be accessed in ASM with NN as in MOV RAX I64 and GLBL underscore var call I32 and fun call I32 and SYS underscore sim asterisk in JIT ASM code and SYS underscore sim and N fun don't need import. Asterisk all offspring tasks of a task inherit sims. Asterisk the size of and Holy C structure members can be used in ASM VLKS. Asterisk using and I in Holy C or I.UA2 on a local var, I, will force it to noreg. Asterisk using try/catch in a function will force all local vars to noreg. Asterisk an unused gap on the STK is left for reg vars asterisk note. Static function vars do not go on the data heap, no matter the setting of the op underscore glbls underscore on underscore data underscore heap. They may in the future. Asterisk op underscore extern underscore to underscore imports will treat underscore extern as underscore import and extern as import. This allows a header to be used either as a JIT compiled or AOT compiled header. File, snd.dd. Sound is generated with I8 vowels called onas, which are 88 piano key nums, with 0 as a rest. See No to ona, and ona to frequency. God does not want death screens, perhaps, because God has PTSD or soldiers have PTSD. Imagine wounded on battlefields. OS will allow elegant WAV files for export and will allow the creation of simple hardware over the next centuries. File, sprite.dd. A C sprite is an ordered list of these elements, created with. Normally, they are packed together in a list and the address of the first is passed to routines. C:/demo/graphics/spriteplot.hc, :/demo/graphics/spriteplot3d.hc, :/demo/graphics/spriteput.hc, :/demo/graphics/sprite-raw.hc and sprite mesh. Be aware that copying SP, IV, or IS entries with the clip results in duplicate entries with different nums. You can manually remove dupes by editing with and setting to the original number. C:/Adam/gr/gr-spriteplot.hc for how C sprite are stored. File, sprite-bitmap.dd. Sprite bitmap menu help bitmaps have a background color. If you delete to the clip, what's left will be background colored. While drawing, you can usually press C to eyedropper the color under the mouse. Press T for transparent. File, sprite.dd. Sprite edit menu help order of elements matters. They are executed in the order they appear in the sidebar. You can sell or unsell elements graphically, or with text in the sidebar. Then, cut, copy, paste, shift or transform them. You can set the current insert point element by clicking the element in the sidebar and making it red. Insert shifts of origin is an element which shifts subsequent elements. Perhaps, you inserted a sprite elements from the clip and want to shift it around. This command is also useful if you call sprite interpolate in programs. File, sprite-edit-text.dd. Sprite edit as text helps see the format for C sprites. File, sprite-main.dd.
File, sprite sidebar.dd. Sprite sidebar help you can cut and paste elements in this sidebar to reorder, delete or duplicating them. Click an element in the sidebar after you make changes to cause the changes to take effect. You can click on an element to make it the insert point for new elements. The red element is the current insert point for new elements. File, standby.dd. Auto-completed in standby system keys quick guide, works everywhere, left click right click help personal menu save and exit abort and exit pull down menu tongue, works everywhere, God word God passage God song God doodle. File, start.dd. TempleOS v5.03 public domain operating system help and index, quick start, CMD line. File, standard out task.dd. There is one C doc for the tasks border, F, border underscore doc. There is a pair for the tasks client area, F, put underscore doc and F, display underscore doc. You can, optionally, do double buffering, otherwise F, put underscore doc is the same as F, display underscore doc. C, skeptical smiley demo /spyhc. File, TempleOS CDD. The standard TempleOS PC or desktop PCs will have 8-channel ARC super simple high-speed serial ports to replace USB. They are simpler because the driver is as simple as old-school RS-232 serial. They have no USB endpoints and they have no USB human interface device reports. Computer mice will all have exactly 2 BTTNS and 1 wheel. Game controllers will all be the standard deluxe game console controllers that are popular today. It will have 8-bit TX and 8-bit RX FIFOs that allow flow control characters to jump the queue. It should be locked down to as few options as possible, like 8 to 1N only, although hardware may use a USB frame, not an RS-232, so stop bits might not be relevant. Perhaps, just two baud rates high and low speed are needed. Low speed is good for slow microcontrollers and allows longer cable length. Keyboard, mouse and game controller can be low speed. The USB creators ban generic devices, requiring a signed, certified driver for everything. That's no good. We allow any device and will communicate, generically, using a serial terminal program like the old-school hyperterminal, Xtalk or Telnet. A mouse packet interface should be similar to this: TX, RX, X colon plus 3Y colon plus 0 wheel, plus 0 pound, off RB, off TX, RX, X colon plus 0Y colon minus 1 wheel, plus 0 pound, on RB, off. We aspire to be as simple as a Commodore 64 joystick driver. Val equals peak, 5632-1. If val and 1 then y equals y minus 1. If val and 2 then y equals y plus 1. If val and 4 then x equals x minus 1. If val and 8 then x equals x plus 1. The game controller will be more complicated, but much simpler than USB. It will use a standard text packet of some kind. On the other end, you might hook up a thermostat microcontroller and interface as a generic serial device. The microcontroller in the thermostat would have something simple, not a crazy overkill Ethernet connection. U8B, while, true, B equals regulate, 2, / read byte from high-speed serial channel 2 / left parenthesis has been configured for low baud because thermostat should be slow. If B equals CMD _up, temperature ++, else if B equals CMD _down, temperature. Super simple block devices will replace ATA /ATP hard drives and CD /DVD Blu-rays. Today, the industry is in flux with a volatile memory just invented. We want a super simple block device interface for non-volatile memory and for what is currently USB memory sticks, but only if they can be made without bad blocks. I don't think we want to deal with bad block memory, so maybe we will not do NV memory. The standard TempleOS desktop will require a hard disk. There will be minimal commands: read _block, write _block, get _capacity, get _model, get _serial _num, and eject. We want a CPU mode with virtual I/O port addresses similar to how paging creates virtual memory addresses. We want a 6553 6-word lookup table that converts virtual I/O port numbers to physical I/O port numbers. There will be a standard I/O port configuration, so port numbers can be fixed in the code. We want the primary hard drive on one set of ports and the primary CD /DVD Blu-ray on another set of ports. Choose a contiguous set of I/O ports. Meanwhile, a complicated PCI interface can be designed alongside the TempleOS interface for Windows and Linux. It would almost be possible to carry on separate lives. However, the Super Simple Serial requires getting rid of USB since Super Simple Serial is a new hardware standard. People can add USB ports with a PCI device card. God said he wants single voice 8-bit signed MIDI-like sample for the sound. God does not want death screams, perhaps. Because God has PTSD or soldiers have PTSD. Imagine wounded on battlefields. The video will be a linear frame buffer 640x480 16 color with 1 byte per pixel even though it is only 16 color with is 4-bit. Perhaps, we have an interrupt to sync with the refresh. I am tempted to help amateur hardware device designers by making the hardware interface for the PC simple. I have fond memories of 1993, when I made a wire-wrapped ISA data acquisition card which plugged into my 486 and had some analog to digital and digital to analog converters. I am not designing a bus. Earlier, I said the super simple high-speed serial port replacement could be USB-like in hardware as long as the software driver interface was simple like old-school RS-232 serial ports. Requiring a complicated hardware handshake raises the bar slightly for the lowest-level hardware designers. Most people will be connecting a microcontroller or something that already has a serial communication design. But if it's not a problem, maybe we should keep it simple at all stages. It was nice putting an oscilloscope on my serial port wires. The original PC had general-purpose digital I/O through the parallel port. That was fun. I have enough battles to fight, so I'll leave being a savior to hobbyist hardware engineers to somebody else. Digital cameras will be super simple high-speed serial. But TempleOS is forever limited to 16 colors and multimedia is banned because large files being loaded into memory fragments memory, so cameras are somewhat unwelcome. I have enough problems without making the Brits anxious about autonomous gun turrets and killer robots. The reason I say cameras will be super simple serial is because we are replacing USB ports with super simple serial. PCs will have only super simple serial ports unless people buy a USB PCI expansion card. So, the digital cameras will be super simple serial. Version 1.0 we will make a spec for $8,000, perfectly standardized, cryogenically cooled, monster desktop PC. It will have 16 cores, integrated 4 Kelvin graphics, and, hopefully, 6 GHz continuous operation. Perhaps 64 GB of RAM will be standard. God said to help to call by them. It is pointless to have a high-powered machine if other people have wimpy machines and cannot run programs you write. Therefore, everybody in the developed world will buy a standard TempleOS IBM PC over the next 10 years, so that will be a quantity of 400 million. Perhaps. God said to pay the US national debt with the revenue. We will standardize everything, not just the TempleOS related items. The display will be 4 Kelvin, and of course 640 x 480 16 color, and no others. Everybody gets just one monitor, unless you buy special PCI cards. Everybody gets 2 speakers, a headphone, a mic, a webcam and touch SCRN. We make the audio 1 sample rate and 1 sample size, but TempleOS still gets just a square wave. HD audio is really screwed up and requires complicated artificial intelligence, just to route output to speakers. The standard Temple IBM PC will be a full-sized tower. Perhaps. Stained glass will decorate the case because God is sentimentally attached to stained glass. We should set the size at exactly 2.5 feet by 1.5 feet by 1.5 feet as in the Exodus, 25, 10 to 10 for all time. If there is extra room, make a storage shelf for DVDs. We do not want a race to the bottom, shrinking the size. Instead of making it smaller, make it more powerful. We want to remove all cost pressure from making things small. It must have a CD/DVD/Blu-ray drive. The vision is CD/DVD is used for a library of games, not installed on a hard drive. We need a network connection, possibly implemented as a super simple high-speed serial device. What about standard monitor and speakers? The C64's success was partially due to widespread, completely standard, hardware. I think TempleOS will not do bad block devices, so we need a hard drive, not just NV memory or SSD. TempleOS will have the priority over Windows or Linux on hardware decisions. We could make it heterogeneous multi-core. I think we want 16 non-hyper-threaded cores. Core #0 is the only full-featured core needed. The other cores will have long mode, but not some of these: real mode, protected mode, ring -3, paging, interrupts, in/out port instructions, SSE instructions, MMX instructions. God said Intel should do a simulation of heat produced by gates and try spreading out the heat-producing gate circuits on the chip. God said Linux's wine should replace Windows. We will install a standard software setup on all standard Temple IBM PCs. Usage TempleOS is primarily for user developers, like the Commodore 64 was. I created a total of 50 meg of content over 10 years, so you shouldn't need much room, either. The installed hard drive space should stay small because the resolution is low, multimedia is banned, third-party libraries are banned, and applications can be distributed with ISO files or DVDs. The ROM will have a command that copies the ROM onto the hard drive, creating identical C and D partitions, so you can have fun modifying TempleOS. You will have confidence you can fix it easily if you break it. It should be able to run everything from just the ROM, too. You will need to specify a /home directory that is not in the ROM, but on the hard drive. The standard setup will be a C primary drive and a D backup drive. Keep the size on each hard drive under 512 meg and periodically copy all of C to D, so they stay mirrored. The file manager and other programs read the entire directory structures, so too many files causes problems, unbearably slow. Third-party software should be distributed as ISO files or DVDs, like Text Adventure ISO. No third-party libraries are permitted because they circumvent the intent of the 100,000 line of code limit, which is keeping it cognitively small enough to see the light at the end of the tunnel and easily master everything. Therefore, third-party ISO files must bring all required software components with them, except what is found in the TempleOS ROM. Having all your third-party software on separate DVDs or ISO files and TempleOS running from a ROM keeps it delightfully simple, so you have complete understanding of what is going on. You will have complete confidence and it will be a joy to use. Third-party applications can store saved data files into your /home hard drive directory. The Temple PC will stay unchanged for 7 years at a time. The Bible speaks of a 7-year release in Deuteronomy 15:1. The Commodore stayed unchanged for many years and people became intimately familiar with every aspect. I thought 2.5x 1.5x 1.5 was ridiculously big, but it looks like it is reasonable for supercooled refrigeration systems. Version 2.0, the standard Temple IBM PC v2.0 will be released 7 years after v1.0. Each unit will have a full, uncut, silicon wafer. v2.0 will be sold, unchanged, for 7 more years, like a Commodore 64. Commodore 64 is a trademark owned by Philip Holding NV. Linux is a trademark owned by Linus Torvalds. Windows is a trademark owned by Microsoft Corporation.
Decisions making TempleOS simple. Everybody is obsessed, Jedi mind tricked, by the notion that when you scale up, it doesn't get bad, it gets worse. They automatically think things are going to get bigger. Guess what happens when you scale down? It doesn't get good, it gets better. I limited it to 100,000 lines of code, forever. I never need a linker or make utility, and I can use small labels. People mock Bill Gates for 640K should be enough. I say, 2 gig for code should be enough. The same people who mock Bill Gates are probably just like the black woman who sued for $1 trillion. My dad worked on converting the Titan missile to the Gemini mission rocket. It had to be man-rated. You can bet that everything got an order of magnitude more complexity and documentation. My vision is a souped-up C-64, not a 1970s mainframe, a kayak, not a Titanic. Linux is a semi-tractor you need professional drivers for 20 years. Linux has file permissions. Common people are hurt by file permissions. Windows is a car. TempleOS is a motorcycle. If you lean over too far, a motorcycle will crash. Don't do that. There are no side airbags on a motorcycle. DOS and C64 had no memory protections and ran in ring 0, with no security. This saves an order of magnitude complexity. Linux and Windows are general-purpose operating systems. They attempt to do any task you want. TempleOS cherry-picks tasks and is designed to do the same things the C64 did. This saves an order of magnitude complexity. For example, the Red C file system allocates just contiguous files you load and save whole files at once. A benefit is this allows compression. Also, TempleOS does not do networking or multimedia. In theory, memory will fragment with lots of big files. The system would fall to pieces with multimedia, but God said 640x48016 color is a permanent covenant like circumcision. A 3BTTN mouse is like a leg you cannot put weight on. TempleOS just does hardware everybody has, with no divergent code bases for each machine's custom hardware. There is one graphics driver instead of 50 for different GPUs. This saves an order of magnitude complexity and makes for a delightful API, so developers' code is not like a frayed rope end. Everything runs in kernel, ring 0, mode. *1 memory map for all tasks on all cores with virtual addresses set equal to physical, just as though paging is not used. *1 platform x86_64 PCs, no 32-bit support. No security or cryptography. No networking. Least, greatest, common denominator hardware support. Mostly, one driver for each device class. I can't be in the business of different drivers. Compatibility is the greatest challenge for PC operating systems. Disk code does not use interrupts, avoiding compatibility risks. PS/2 keyboard/mouse is used instead of USB, also more compatible. *640x48016 colors. Updates hold SCRN at 30 FPS, optimized for full SCRN games where invalid rectangles are counterproductive. *1 font, 8x8. Text and graphic layers done in software with text normally on an 8x8 grid. It can run in text mode if graphic initialization fails. Compiler extends all values to 64-bit when fetched and does only 64-bit computations intermediately. Assembler has minimal 16-bit support, good enough for compiling bootloaders. No object files. UseJIT. Whole files are processed almost exclusively, allowing compression. *1 language and compiler for command line, scripts, songs, automations and code. *1 editor/word processor/browser for the command line window, source code, documentation browser, dialog forms. No child windows. One window per task. BTTNS are widgets, not child windows. There are child tasks, however. No distinction between thread, process, or task. The scheduler is for home systems. It is not preemptio. Disk requests are not broken up, so sharing is bad. It's wonderfully simple. Multi-core is done master/slave, instead of SMP. Core0 applications explicitly assigns jobs. Locks are present allowing multi-core file, heap, and hardware access, though. Asterisk sound has single voice 8-bit signed MIDI-like samples. Asterisk all tasks have a heap and a sim table. Scope is that of environment bars in other operating systems. As text is typed at the command line or you run programs by number including them, the sims go in the table. If a sim is not found, the parent tasks table is checked. The father of all tasks has the API sims you'll need waiting in its table. No need to number include headers. Asterisk no need for namespaces. Scoping occurs automatically based on task symbol table hierarchy with the atom task symbol system-wide global. Asterisk sometimes, I cut corners in the interest of keeping the code beautiful. File, streams.dd. There are no streams in the traditional sense. The CMD line output gets sent to the cursor location of a document being edited, and by using cursor keys, text can be injected all over the document. Sprites can be injected and are not serialized. Furthermore, the input can come from triggering macro widgets. See doc overview and doc routines. If you had a remote term and sent key scan codes, the user would press to access his personal menu to trigger his macros. However, the local /personal menu.dd might differ from the remote, causing loss of sync between local and remote sessions. Also, the window size of local and remote might differ, so word wrap text would be different. Injecting output text with different window sizes would cause remote and local documents to not be in sync. See char overview and char routines. You can send characters into stdin, cin, xtalk, and in file. File, tosc.dd. Linux tosc utility tosc ASCII file name will uncompress a single file from within Linux. The ASCII flag will convert the irregular TempleOS ASCII 5 and ASCII 31 characters to spaces. ASCII 5 is used to mark the cursor POS and ASCII 31 is used for shifted space characters and will cause problems unless you convert them. Asterisk Linux is a trademark owned by Linus Torvalds. File, textbase.dd. grtext_base must be updated 30 fps in your fsdraw_it. Callback. You probably want grprint, or just print. The dole.doc code takes care of plotting text to grtext_base. Bits 0 to 7 8-bit ASCII SCR encode, bits 8 to 11 foreground color, bits 12 to 15 background color, bits 16 to 20 signed XPOS shift val, bits 21 to 25 signed YPOS shift val, bit 28 blink, bit 29 inverted, swap foreground and background, bit 30 cell, X or colors with FF, bit 31 underline gr update task win, calls doc update task docs, which calls doc recalc, where the document text is plotted into grtext_base. Then, grupdatedxbitch, and grupdatedx, render the grtext_base onto grdc2, a raw graphic bitmap. C:/demo/game/maze.hc. File, timecycles.dd. Intel/AMD have an INST that returns the number of CPU cycles since boot. This is not a steady, calibrated real-time value. TempleOS measures it and you can convert with cnts.time_stamp_frequency, a value continuously calibrated from other CNTS. File, timedate.dd. TempleOS uses a 64-bit value, cdate, for date/time. The upper 32 bits are the days since Christ. The lower 32 bits store time of day divided by 4 billion, which works out to 49710 ths of a second. You can subtract two dates to get a time span. Use date_frequency to convert. File, timehpet.dd. The HPET, high precision event timer, is read with HPET, and has a frequency of cnts.hpet_frequency. A typical frequency value is 14.3 MHz. It might not be available on all systems. File, timejiffy.dd. 1 jiffy is 1 time slice. cnts.jiffys returns time slices since boot. SYS timer read reads the timer ticks since boot. It's not as fast as getTSC. Use jiffy_frequency to convert CNTS.jiffies. Use sys_timer_frequency to convert sys timer read. File, tips.dd. Tips * turn off or reboot, at any time, except during disk writes. Writes are not cached. * use seed, and the CMD line to switch RAND, to non-timer mode and replay games you like. * 64-bit values are most efficient for the compiler. * C key map for a list of defined keys. Define your own keys in MyQuickKey. See keyboard devices. * maximizes a window. Closes autocomplete. Brings back autocomplete. Vertically tiles windows. Horizontally tiles windows. The Alt keys are defined in /home key plugins.hc. You can customize them. * if you make changes to TempleOS files in your /home directory, generally you reboot to make them take effect. You don't compile anything. You should have 2 TempleOS partitions on your hard drive because a syntax error in a startup file will make the partition unbootable. Boot to the second partition or boot to a standard TempleOS CD/DVD and use mount, to mount your hard drive. * I copy my files to a mirrored ident partition, periodically with copy tree, commands in scripts. I do merge commands with a menu entry like this, merge, \c /\, \d \, +R and D \, to check my changes. * at the CMD line to access your personal menu. Place macros there with, or icon like sprites with. Use the pop-up option on macros to spawn a task to run a file. It dies when it is finished. This returns MEM to the system. Be sure to press to save your macro/menu area after making changes. * you can use ANS in CMD line expressions. It holds the residential the last CMD line operation. You can use the CMD prompt as a calculator by just entering expressions like 1 + 2 * 3. F6 for res can be accessed with ONS. * use the pull-down menu at the top of the SCRN to learn commands, or for finding the keyboard controls to games. * you can adjust the mouse movement rate by setting global bars in your startup file. See mouse scale. * you can set your local time zone by setting the local_time_offset global bar in a startup file. Its units are date_frequency. See local time. * in the editor to indent a holy C function or renumber an ASM routine's local labels. * you can use filter_lines in the editor text search form, to temporarily display just lines near each match. A value of filter line set to 5 will display lines within 5 lines of matches. Then, you can do another find to a different string and achieve and search. When finished, press * you can recompile and reinstall the kernel with bootins. You'll probably want to make a function for recompiling that uses the in function to answer the CFG questions. See my technique CFG STRs, update funds. * scale to MEM, min-max limit equals 21024 1024 1024, can be used for CFG questions when recompiling. The bootins, CFG prompts accept expressions, not just numbers. The DFT disk cache is scale to MEM, 0x80000, 0x8000000. * you can permanently disable autocomplete commenting out a CNIT, in /homesys.hc. * Boolean expressions not in if STMTS don't have short circuit logic and are compiled inefficiently. * you can use progress 1 progress 4 in your programs for whatever you like. They're just global bars that are shown on the wallpaper. The original intent was to indicate how far along operations were. There's no coordination, so different apps might interfere. I use them most for debugging just values easily viewed. See :/demo/progress.hc. * use docmax, to adjust the size of the CMD line buff. It counts CDoc entries, not lines. Asterisk many data structures have a user_data member. Those are available for you to store a data item, for convenience. C task, DOS entry, and entry have them. You shouldn't encounter conflicts with TempleOS using them. Asterisk if, for some strange reason, you wanted to reduce MEM usage, make a smaller disk cache when you recompile the kernel, disabling autocomplete, specify smaller STK sizes when doing spawn, chung MEM_EFT_STK, and using docmax, to reduce the CMD line buffer size. Asterisk file names ending in .z will be automatically compressed and uncompressed when read or written. The compression method is not supported by other operating systems. You can store files uncompressed by moving them to a file name not ending in .z. C:/doc/tosc.dd if you want to uncompress while in Linux. Asterisk merge can be used to see what's changed. The -d flag will show differences of files which have changed and allow you to merge code. The -r flag will recurse. Asterisk there is a utility link check, which will check for broken links in documentation. Asterisk you can use option, op_warn_paren on, to find unnecessary parentheses in code. Asterisk you can use option, op_warn_dup_types on, to find unnecessary local var type statements. Asterisk option, op_echo on, can be placed in startos.hc to echo startup scripts. Asterisk use plain, to edit a plain text file. You'll need this if your file has $s. Use the $doc utility to convert plain text to $docs by doubling $s*. Use silent, to disable scrn text output. Asterisk grab scroll any window at any time with control left mouse drag. Null grab scrolling with control right mouse. Asterisk use to zoom in and to zoom out. You can scroll by moving to the edge of the window. Set continuous_scroll to true if you want. Asterisk use and to display a grid on the scrn. Asterisk use to enter an extended ASCII character. Asterisk use to toggle between STD font and Cyrillic font. Asterisk use will capture the scrn as a sprite on the clip. You can save the CMD line doc as text with. Asterisk you can save a sprite as a .gr file on the sprite bitmap menu. Asterisk you can eyedropper colors in the sprite editor by pressing C. Press T for transparent. Asterisk there are handy functions F, R, FD, and RD, which are defined in /home wrappers.hc. You are encouraged to change them and add more. They will perform find and replace operations across multiple files. The &L flag is particularly useful since it limits to whole labels. The &LB and &LA flags limit to whole labels just before or after. You are encouraged to add or modify handy wrapper functions to make CMD line operations easier. Asterisk when using find, while modifying code, work from the bottom up so that line numbers are correct. If you work top down, then inserting or deleting lines causes the lower file links will be incorrect. Asterisk you can save files after making changes, anytime you are within the editor, like when viewing help/macro files. Saves as, saves with the same name in the scrolling title bar. Hitting will exit and save. Will abort. You can save the CMD line window to a file, too, since you're actually in the editor when you're at the CMD line. Asterisk when using to insert links in documents. You can usually leave the TAG text blank and it will be filled in automatically based on other entries. Asterisk there is a feature of the precompiler that allows code to be executed in the middle of compilation and data inserted into the compilation stream. Click here for an example, number.exe. Asterisk if you output to the CMD line and wish to allow users to scroll around and view data, you can use view. Asterisk use view in pop-up macros to linger until the user presses or. Asterisk you can access the word under the cursor at @cur_word. Asterisk you can reactivate autocomplete after closing it by pressing or if you have it defined. Asterisk to toggle to slash from plain text just the c.cmd under the cursor. c:/demo/dol-doc/text-demo.hc. Asterisk if you toggle to plain text when you are working with graphics in a document, you can add duplicate entries for sprites by entering a $sp. $cmd with the same number. Asterisk if you toggle to plain text when working with graphics, you can add a str to the $sp. $entry to keep track of it. Try $sp by equals $2 where 2 is the sprite number. Asterisk I use spaces to have operations on all my src files to keep them small. You have to be careful, though, because spaces in strings will be converted. I use in such cases cs2t, for spaces to tabs. Asterisk you can edit an existing sprite by putting the cursor on it and pressing. Asterisk when editing a sprite, you can cut and paste the elements in the sidebar text list window. Asterisk I recommend keeping C-sprite in vec format until you are done creating them, so you can edit the control points. Then, convert them to bitmaps, so the plug fills work well. If you are doing interpolation, however, they must be vect. Asterisk gr plug fill is slow. Gr rect is fast. Asterisk you can customize the wallpaper. c:/demo/graphics/wallpaperfish.hc. Asterisk your RAM disks will not be reformatted when you reboot if the memory location has not changed and it finds the disk intact. Asterisk try catch in a function will cause all vars to be non-red. Asterisk using a subint array, i.u83, for example, will force a local var to non-red. Asterisk you can delete the /registry.hc.z file. The policy is that deleting it will restore defaults. It is a text doc, if you want to edit it. Be careful of tree indentations. Asterisk study :/adam/opt/util/memrep.hc and wallpaper, to learn how the system resources are put together. Asterisk the editor's cell text mechanism allows for disjoint portions of cell text. This is a feature, not a bug. You can cut and paste disjoint text. Asterisk cnts.time_stamp_frequency is continuously calibrated. Be careful because expressions might decrease. Take a snapshot, like this, timeout equals get tsc plus cnts.time_stamp_frequency x seconds, and compare against get tsc. I recommend just using ts or cnts.jiffies. Asterisk use heap log address rep, and heap log size rep, to find leaks. Don't be confused by cdoc allocations. Those are generated when text is written to the CMD line buffer. Asterisk for advanced heap debugging, play with _cfg_heap_dbg. You're on your own. Asterisk you can use type, to display .gr files. Asterisk use man, to jump to short sim name src code. Asterisk use fix, to edit and fix the last compiler error. Asterisk you can use to do a check for compile errors. Asterisk you can use docopt, to optimize links. Mostly just removes .z, asterisk ziprep, can highlight src files with lots of redundancy. Asterisk with start/end, common trailing code is fast. Common leading code is slow. Asterisk the first line of the Samadi Holy C song files is a comment with a category recognized by Jukebox. The categories are know nothing, has words, has graphics, or special. The third character in the song comment is a digit rating number, shown in Jukebox. You can set the song rating in Jukebox, by pressing 0 to 9. You can press to delete songs. Asterisk Linux is a trademark owned by Linus Torvalds.